So today we are going to be continuing our epic adventures of balancing chemical equations. So epic, I kind of got stuck on that word there. But we're going to add a little bit of a wrinkle to it. So the equation I'm going to look at today is H2SO4, that's sulfuric acid, reacting with AlNO33, that's aluminum nitrate, to give rise to nitric acid, HNO3, and aluminum sulfate, Al2SO43. So now you probably have a lot of questions about this one. Namely, what does this 3 do to the NO3? Or what does that 3 do to the SO4? How come I have parentheses on one side but not on the other? Okay, so we're going to answer all those questions. So going back to really what we're trying to do when we balance chemical equations is try to get the number of atoms of each element to be the same on both sides. So for instance, I have 2 hydrogens here. I only have 1 hydrogen here. It's I would want to get those equal because I can't just have hydrogens appear out of nowhere. A chemical, a chemical equation has to account for where all atoms of an element are. So I would say let's start off by drawing some kind of blanks in front of our substances, in front of our compounds or molecules. Now, typically what this 3 does, and you'll see this sometimes, is this 3, if I don't click like that, this tree essentially means we have 3 sets of NO3. This is kind of what we learned back with ionic bonding, is that means I'm going to end up with 9 oxygens here and 3 nitrogens. Essentially, for this to work, because aluminum typically has a charge of positive 3, NO3 has a charge of negative 1, I need 3 NO3s in order to kind of balance out the positive 3 on the aluminum. So now it's like, okay, so typically when I do this, I go to list things out. The way that you might knee-jerk want to do this is I have a hydrogen here, I have a sulfur here, I have an oxygen here, I have aluminum here, then I've got nitrogen, and I've got some more oxygens. You might say, let's put some equal signs. I've got 2 hydrogens, 1 sulfur. I've got 4 plus, we said that was 9 oxygens, so 13, 1 aluminum, and 3 nitrogens. And you very well could do that. List out both, list that out over here too. But there's an easier way to do this because like trying to figure out, multiplying with this 3 in there, then you got to multiply this out here. Let's look at this kind of in an easier way. So I'm going to do that. I'm just going to go ahead, kind of get rid of this jazz. Guess I didn't need to get rid of the line. All right, that line goes there. So I have hydrogen. Now in this case, here's kind of the new rule we have. If I have something in parentheses on one side of the equation and it's not in parentheses on the other, go ahead and put it in parentheses. So in this case, I've got NO3 in parentheses here. I have NO3 together over here. So I'm just going to put parentheses around it. I have SO4 in parentheses here. I have SO4 together over here. Put parentheses on it. Now when I go to list out elements, kind of like when we did ionic bonding where, like, let's say I have hydrogen and I had this. I said put the SO4 in parentheses. This way when you crisscross, we're not touching anything in the middle. We're still going to do that. If it's in parentheses, we're not going to worry about any of these numbers. I'm not even going to really worry about what it is. I'm just going to put SO4 in parentheses, or write it down here. If it's in parentheses, treat it like it's one thing. With our covalent bonding, we kind of learn it does act like its own little ion. So I've got hydrogen, I've got SO4, I have aluminum, and NO3 is in parentheses, so I'm just going to leave NO3 together over here. This side, I'm just going to leave things in the same order. And NO3. All right, so now when I go through to do this, I have 2 hydrogens. Figure out how many SO4s I have. I'm going to look right here, just on the other side of this parentheses. There's no number there, so it's implied it's a 1. I have 1 aluminum. I have NO3. I'm looking down here on this side of the parentheses. There's a 3 outside of the parentheses. So I've got 3 NO3s. Over here, 1 hydrogen, 1 NO3. I'm looking at 2 aluminums and 3 SO4s. All right, so now looking at this, I've got, thank you, Flipboard. 2 hydrogens here, 1 here, 1 SO4, 3 SO4s, 1 and 2 aluminums, 3 and 1 NO3s. All right, so in this case, there's really not a bad place to start. There are some that would require me to go back and redo some things. I would say let's go ahead. Let's just start with hydrogen here. I've got 2 hydrogens here, 1 hydrogen here. So if I put a 2 here, that changes my hydrogens to 2. That changes my NO3s to 2. But now I have a little bit of a problem here. I've got 3 NO3s here, 2 NO3s here. So rather than trying to get 2 to 3, let's just go least common multiple for these two. Let's try to get both of these to 6. So now, I'm going to need a smaller brush size now. Let's not have a 2 there. If I need my NO3s to get the 6, if I have 1 NO3 here, 6 divided by 1 is 6. Let's put a 6 there. Now I don't have 2 hydrogens. 6 times 1, I have 6 hydrogens. Just now, let's jump over this way. I have 2 hydrogens in the H2SO4. 6 divided by 2 is 3. So that gets me to 6. And now there's 1 SO4 here times 3. I'm at 3 SO4s. Okay, not bad. So now we need to look at, so now it doesn't matter. I can look at my aluminums. I can look at my NO3s, which I forgot to come back and do actually. So now if I have 3 NO3s here, I want to get to 6. 6 divided by 3 is 2. That's going to change that. That already changed. So now I have 2 times 1, 2 aluminums. All right, so now go back, kind of look at the numbers we added to figure out how that changed these numbers here. But now if I double check, everything's balanced. The big trick with working with polyatomic ions with balancing chemical equations is if it's in parentheses on one side and it's together on the other side, go ahead and put it in parentheses on the other side. And then when you go to list out your elements, just put what's in parentheses together, because essentially we're not going to change those numbers. Those things are going to stick together. If you wanted to separate it out by like the sulfurs, the oxygens, the nitrogens, you can do that and you can get it balanced. I just think it's a lot more work that we don't have to do. So with that, there are some practice problems. Good luck.